see. So today, I'm going to share with you all my experience of building the modular pipeline feature for the Kedro-viz project, which is a web tool for visualizing machine learning pipelines. But first of all, like all great introductions, let me start with a huge friendly hi to everyone. I'm Susanna, and I'm a front-end engineer at Quantum Black, where I'm currently part of the core team for the Kedro-viz project, which is a tool to visualize machine learning pipelines that are built on the library. Well, I mean, what the heck is that? Don't worry, I'm going to walk you through all of that in a second. I'm also a Google developer. And fun fact, I used to be a computational designer / architect, where I had been using code to solve a lot of design problems in architecture. So if this is something that you're interested to talk about, please definitely hit me up during the, well, we don't have a break, but hit me up later. So before I dive into the Kedro-viz project, let me introduce you to Kedro, which is an open source framework for creating modular data science code for production. So currently, a lot of data engineers and scientists use Jupyter notebooks to develop their machine learning pipeline locally on their machines. So I guess maybe some of you know about Jupyter notebooks if you have dabbled a little bit with data science and machine learning. And you can think of it as like kind of like MATLAB when, in your college classes. That setup is extremely hard for them to collaborate with the team on work, and not to say to turn it into production code that can be deployed on the cloud. So what can we do by allowing to build modular data science code using software engineering principles that can be they can easily versioned by Git and hosted on remote repositories. Sound familiar? Because Kedro is pretty much the React for data engineers and data scientists, where we also advocate the use of the same goodies of software engineering principles towards developing modular data science code. So within React, we can all visualize our work easily by building and running the local version of our app. But with data scientists, as they develop their pipeline, they also face the problem of not being able to make sense of the pipeline that they build. Especially, it can be a very complex pipeline as the pipeline grows through collaboration with the team. So this is where Kedro-viz comes in. So we are a web app that provides an interactive flowchart of the latest pipeline that the user has built on Kedro, where they can also access some further details of each node, as you can see on the right, that they've developed within the Kedro project. So the setup is very simple. Within the Kedro project, the user can spin up the Kedro-viz app via this CLI command. And from the Kedro project, in the middle part, so the Kedro-viz server will be able to obtain this following set of information that is crucial for the construction of the interactive flowchart. So first, you can know the set of pipelines that are constructed within that Kedro project. And the second one, line. And by the way, nodes are basically Python functions that are defined to perform specific tasks in a pipeline. And of course, we have the edges that will link up the nodes to form the pipeline. And finally, a set of tags that is defined in a pipeline, which the nodes can be assigned a tag for easy filtering of the set purpose that is defined by the user. And all this huge set of information is served as this giant nested object, where Kedro-viz will use it to construct the interactive flowchart. So our stack consists of, well, surprise, surprise, React, with Redux as our state management tool, but we are transitioning into GraphQL. And D3 in constructing our interactive visualization. So before we dive further, let me walk you through a little bit about our architecture, which is very different from that of a traditional web-hosted app. So one important deviation is that we are a locally hosted app, no remote server, and our hosted data is within the Kedro project, which sits within the user's local drive. And on spinning up the Kedro-viz from the command line, a locally spawned Python server, as what you see in the middle there, will serve this data to the Kedro-viz app via 3 main endpoints. And there is a main endpoint which provides a set. So on having fetched this huge data object that I've shown you in the earlier slide, the app will go through this initial data congestion phase where we will break down that giant object into what we call something called the pipeline state, which, by the way, we have a local storage setup where if the user has previously loaded the same Kedro-viz app of the same pipeline, we will also combine that data together, as well as we will have a set of non-initial app state, which we call the non-pipeline state, to form the global Redux store in serving data to populate various parts of the app. And here what you can see is that this is the overview of the front-end app and our data flow. And we have our app is, in terms of structure-wise, it's straightforward in that we have 4 core components that makes up the visualization. But each component, you can think of it as a giant section, which and all these 4 components have very high interactivity between them. So you can see here we have the sidebar on the left, which you can think of it as a control panel, which will control and filter the set of nodes that are visualized on the flowchart. And the second one is, of course, we have the flowchart, which will visualize the pipeline. We have a mini-map component, which will allow the user to quickly navigate different parts of the complex flowchart, kind of like when you play games, you have a mini-map down there. It's kind of like that. And also we have a metadata panel, which will display further information about each node. So, and also, as I mentioned, each component is highly correlated to each other in terms of interactivity. For example, if we change something on the sidebar, all the flowchart, minimap, and metadata panel will have all the corresponding changes. So, in other words, this is when Redux will really come into place in providing a high-performance updates of app state to trigger all these changes in the different parts of the app. So on the subject of Redux, one important thing that makes our app different from others is how we heavily utilize the selector setup in updating even just the calculations of the component itself. So in other words, we don't use hooks, but we rely solely on so we had set up a custom selector to update the component state and conduct the calculations. So for example, on the right here, you can see a sidebar component itself. We have the sidebar component itself is a giant component that consists of 8 subcomponents, and all of them are highly correlated to each other. So instead of setting up hooks to populate the components via props and passing it everywhere, so we have set up a custom sidebar selector to perform all the relevant calculations and updating the state when we get all this new pipeline data from the global store. And the same goes for the flowchart component. We also adopt a very similar setup of a custom flowchart selector to perform all the required calculations to generate the flowchart. So after all this introduction of our app, so let us jump to the core of this presentation, which is the set of features and updates that we introduced to Kedro-viz since the introduction of modular pipelines on the Kedro project throughout the early half of 2021. So what is a modular pipeline, you might ask? So as you might recall, a pipeline is formed by joining different nodes, like here what you see, node A, B, and C. So now you might want to reuse this configuration in a later stage when you construct your pipeline. And by defining that configuration as a modular pipeline, you are now able to reuse and reference that modular pipeline at various different stages, like individually redefine all the nodes again. So you can think of it as Lego. So with Lego, you have all these fundamental building blocks. But let's say you have assembled a race car component. You can now call it a race car and use race car to refer to that configuration required elements to assemble that every time. And since the introduction of this ability to define and reuse modular pipelines in the Kedro project, so our team, the Kedro-viz team, started to look into new drastic changes to support this new way of pipeline setup. So what you see here, line version of Kedro, you can see on the right here, our sidebar on the most right. So our sidebar is mainly consists of we will list all the elements by just 4 flat lists. We have tags, nodes, data sets, and parameters. And on selecting individual tags, literally as what you see here, allows you to filter out the associated nodes on the flow to select a certain node. On the sidebar, a metadata panel will pop up and it will give you all the relevant information of the node via the metadata panel on the right. Okay, so, yeah, sorry. So now the introduction of the modular pipeline feature on Kedro will mean new changes to the. So for example, on the most right, you'll see that we have now a new modular pipeline field that will list all the defined modular pipelines on that in that node object on the right here. We'll have a new modular pipeline field that will tell you which modular pipelines that node belongs to. So before our team dived into a redesign of the UI and start building everything, we followed the agile best practices and built a first version MVP with tags, as I mentioned earlier. So you are able to filter out the associate nodes on the flowchart. And here we apply the same concept where on the sidebar here we had lists out all the modular pipelines as a nested list on the sidebar. And then we apply the same concept where on clicking it, we will filter out all the modular pipelines. And you can select different modular pipelines similar to how you do it with tags to filter out the selected nodes on the flowchart. So you can see which modular pipelines are defined in that project as well as what nodes belong to that modular pipeline. So that first MVP proved to be a feature that's loved by our users. So it brought us to the next step in starting to look into how we can introduce that drastic change to our current sidebar UI. So now instead of listing the 4 sets of elements as a flat list, we're now displaying them following the hierarchy of the modular pipeline tree. So the main reason is because we want the users to adopt the modular pipeline mindset in accessing their pipelines on the sidebar. So you see here, everything is wrapped in that hierarchy of a parent, child modular pipeline, and so on the sidebar. We have also introduced drastic changes in our search UI. So before, when you search for something, it will just display everything according to the arrangement of the 4 flat lists. But now the results will be displayed under the modular pipeline tree hierarchy. And then as what you can see here, the search results are also nested within the parent pipeline, even if the parent pipeline doesn't contain any of the search keyword. So this drastic change will introduce a series of challenges that fundamentally change our logic calculation of the sidebar, and which is the whole setup of our selectors that I've shown you before. The first challenge in doing this is that we have to tackle this construction of a tree structure from a completely flat list, as what I've shown you before. So first of all, we can take a deep dive into that data setup and how we can make sense from that in relating that to the tree hierarchy. So here you can see that we have adopted the concept of namespacing in our modular pipeline ID. So if you can see here we have, let's say for example, the second pipeline, pipeline1.pipeline2. It means that this is a level 2 pipeline with the parent pipeline is pipeline 1. And the similar concept is the same for this later pipeline, which is pipeline1.pipeline2.pipeline3. That's the ID. But what it means is that that is a level 3 pipeline with the pipeline 2 as its immediate parent. And so you can see here, this is the hierarchy as what you show here by the namespacing. And then also one important thing to know is that with the flat list of data that was being sent, the modular pipeline returned in that array is not going to be arranged by hierarchy, meaning that the order of the elements can be completely aligned on the list. Can be on the 3rd level of pipeline A, of the parent pipeline A, and the next one can be on the 8th level of another modular pipeline. So we have to assume that none of the that list has no hierarchy, and we cannot make sense from it just by the order. Now the modular pipeline field within node will also list all the modular pipelines that node belongs to. So for example, here you can see this inner node will now belong to both parents because it's nested within the modular pipeline that is the child of another modular pipeline. It's the problem of sorting the elements to construct the modular pipeline tree, which in theory, it can be infinitely deep. There's no limit as how much it can be nested. It can be, one modular pipeline can have 3 child modular pipelines, another one can have 11, so we cannot limit that. So the first step, how we modular pipeline pipeline that will define the state of that, of that module pipeline node as to how it will behave on the flowchart. That's step 0. And then the next step is that we will construct a main tree object that will represent the main, like, what you see in the bottom is a breakdown of the main concept of how we iterate through all the list of module pipelines to construct the tree. So let's say we have this module pipeline with this ID, which is, you can see it's a level 4 pipeline. So because of namespacing, now we can obtain all the parents of the module pipelines into an array. And in this case, the array will be arranged in a hierarchy of following the tree of the parents. So you can see now you have an array of pipeline 1, and then the second level parent is pipeline 1.pipeline 2, and so on. So the next step is that we will iterate through that array of parents, and starting with the topmost hierarchy, which is pipeline 1. And we will use that to compare with the current parent, which is, in this case, our starting point is always the main parent. And we'll look into the children field to see if the children field contains pipeline 1. If the children field doesn't contain pipeline 1, which is great, that means we have identified a new modular pipeline of the main parent, and we will slot that in and assign pipeline 1 as the current parent. And then we go into a deeper level and start to look into the children of pipeline 1 and to see if it contains pipeline 1.pipeline 2. If it doesn't, we will slot that into the children field of pipeline 1 object, and then assign the new parent pipeline 1.pipeline 2, and so on. So we will further repeat this process with all the parents of this module pipeline until we have finally finished populating all the parents of this module pipeline into its subsequent level in the main tree children field. And this will continue on for all the modular pipelines in that list until we have constructed the whole tree of modular pipeline on that main tree object. So now that we have the logic established to construct that pipeline tree, we will need to tackle this new set of challenges that's placed by the new search UI. So it's really filtered nodes, but we also show the parents of the filtered nodes, even though they do not contain any of the search keywords. So our current search feature ties in our select set of benefits of Redux, in that we will first filter out the set of nodes, as you can see here in our search value. Let's say we put the search value is IN. And then we will first filter out the node, modular pipelines, and the tags that contains that keyword. So with tags, it's to consider the parents for those as well. So that we can split into 2 cases. So case 1, if it's a filtered node, and then we will have 2 selectors, one selector that will simply return the set of filtered nodes. The other selector is that we will actually take that node and find all the parents of that node and put it also into another set, which is the filtered modular pipeline parents for those filtered nodes. And in case 2, we have the same for the filtered modular pipelines. To grab all the parents of those filtered modular pipelines via 2 selectors. And the results from all those 4 selectors will be referenced in that final selector where now that we have the tree list logic defined, we have also further looked into the modular, we have applied the modular pipeline concept into our flowchart visualization. So now if you see the set of nodes that are originally split, but then they were defined as a modular pipeline, they're now condensed and collapsed into a single node on the right. So the user can choose to expand the modular pipeline via the sidebar, which you will see that in a later GIF that I have on a later slide. So another feature that we have introduced is the focus mode feature, where the user can choose to focus on a modular pipeline, where only nodes belonging to that modular pipeline, as well as all the related inputs and outputs, will be visualized in that flowchart. So the focus mode is made possible by the following setup. So if you recall, we have defined in the on the most right, We have defined an object for each node that contains a set of fields that describe the state of the node on the sidebar. For example, you can see like the disabled state, the visible state, and so on. We've also applied a similar concept to construct to modular pipelines, where we introduce a modular pipeline object for all modular pipelines that has all associated state to show how it's represented on the sidebar and flowchart, as you see on the top right corner. So on having selected a focus on a modular pipeline, as what you see in the middle one, so all other nodes that does not belong to that modular pipeline will be assigned an inactive/disabled state, and it will prompt them to be rendered in a lower transparency in the flowchart. That's what you see here. And also remember that first MVP that we've shipped in with modular pipelines, borrowing the concept as tags. Well, we are able to recycle that setup here by filtering the setup nodes to only display the related nodes on selecting the modular pipeline. And of course, we have some further work to also find the associated input and output nodes to construct the new flowchart. So in other words, you never throw away your experiments or MVPs, as you will never know that they can be useful in a later feature. So there you have it. This is the complete set of modular pipeline features that we introduced to Kedro-viz. So as you can see, the user can choose to expand a modular pipeline via the sidebar. And also, we have took the tags out in a separate filter panel on the bottom, and the user can still choose to filter out by nodes, datasets, and parameters. And the user can also search the sidebar, and now the search results will show everything displayed in place in the sidebar, and the inner nodes of the search result will be displayed in the right tree hierarchy, following the modular pipeline tree. So I would have loved to show you all on the demo and click around, but in the interest of time, I don't think I'm able to do so. But that said, the demo is accessible via this link, so be sure to check out our demo here. And we are also an open source project, so feel free to check out our docs and code on our GitHub page and play around with our code. And since the latter half of the year, we have started working on another major feature called experiment tracking, where we allow users to track data sets for each run of the data and compare different data sets via a new UI developed on Kedro-viz. So I have a series of bonus content, which I cannot show you again in the interest of time. Sorry for the teaser, but in a nutshell, this includes our further user research work to explore the different milestones on shipping this feature, as well as our roadmap to fully migrate to GraphQL. So if you're interested, feel free to reach out to me later in the day, and I would be more than happy to run you through and show you around. So thank you, everyone. It's been such a pleasure, and you all have been really wonderful and really patient. And I can't wait to speak to you all throughout the next 2 days. Thank you.